Hi, so let's start with Module 5. So, Module 5 is primarily on the wireless standards. As you're aware, we are focusing only on the cellular standards, right? How the evolution of these generations of 1G, 2G, and all that has come, right? So, that's typically where we are going to focus on Module 5. So if you look at, we're going to quickly take on to the evolution of the cellular standards. So we're going to focus on the 2G, we're going to focus on the 3G, and we're going to focus on the 4G standard. So 2G is basically your GSM, Global System for Mobile Communications, right? So 2G standard is that GSM standard. And then GPRS was the enhancement for providing data services, right? So we're going to look at GSM architecture in this current lecture, and then we will gradually get on to 3G, 4G. So every 10 years, if you look at, we see a generation of standards coming up, right? And the enhancement in terms of now we have very such high capacity, high data rate, internet services, smartphones being there. So this evolution of standards, we will look at the architecture, the protocols, the channels involved in these generations, right? So LTE is the 4G long-term evolution, right? LTE advanced, right, is the next set generation, and then 5G and things came up, right? So that's the outline of this module, right? And so looking at the generation of mobile telephony, if you look at, you've gone through from an analog, right, standard analog communication to a digital communication. Okay, so 1G was purely an analog, communication standard, which had a very limited area of coverage, right? Very limited mobility, and primarily those earlier generations was only focused on voice communication, right? There was no data communication possible. But yes, you had the telephone network. So gradually, these analog cellular phones basically expanded its coverage over a wide area and started to provide mobility within the service area and connectivity to the public switch telephone network, right? But the data communication facility was not there, right? And that's then the generation moved from 1G to 2G, right, where you transition from analog based protocols to a digital standards, right? So 1G, if you look at the AMPS, Advanced Mobile Phone Standard, was introduced in 1980s, which supports only voice calls and was primarily using frequency modulation, and it was using FDMA, right? And the handsets were very bulkier in the first generation. Okay, whereas second generation is where primarily the digitization happened. The GSM standard came into place. Okay, so our focus is going to be on the GSM standard, the architecture of the GSM standard in this current lecture. So the GSM was the beginning of the digital cellular standards, where the second generation arrived, right? And this basically went on to effectively provide voice communication and was able to offer complete mobility within the service area and also connectivity to the public switch telephone network. Primarily, it was for voice communication, and then it was amended where it was starting to provide data communication facility also, right? But there were limitations of as far as internet service and all that. It was low data rate, spectral efficiency was something of a limitation. Then the third generation came in where you started to have much faster internet services, higher data rates, right? And also capacity wise, it was good, right? And then it went on purely on a kind of voice over internet with very high data rates and all that, right? So the evolution of from 2G to 3G and 4G, if you look at all these generations, if you look at, there is basically an organization which is called 3GPP Partnership Project, which comes up with standardizing and coming up with this release of the standard specifications, right? And the mobile network technologies has evolved over these generations every decade. 1980, 1990, 2000, 2010, like that, 2020, 5G, like that, it goes on. So from 1G, right, and then 1990, the GSM, and then the GPRS coming up, with GSM, right, Edge, and then you have the 3G, the UMTS, and then the 4G, the LTE Advanced, the 5G. So things like that evolved, and the 3GPP organization plays a very important role in standardizing and coming up with these releases, the specifications, and all that. So primarily, if you look at voice call, right, this was the primary mode of communication for telephone networks, and mobile was also used for voice communication alone. So it was using circuit switched networks, right, and the circuit gets established for the duration of the call, and then it gets released, right. So that was the idea. And then data session. So primarily, you didn't have data being supported. The packet switch network is not there, and then the GPRS basically amended and came up with supporting data sessions, but at very low data rates initially, and then it expanded. So if you look at these evolution of that, 2G and 3G was using circuit switch network and packet switch network, right? And then the 4G has become an all IP network, the voice and the data. So it's called as Evolved Packet Core, right? And the architecture as such has become entirely an IP based, you know, transmission, right? So that's how things have gone. So UMTS third generation is called Universal Mobile Telecommunication System, right? 2G GSM stands for Global System for Mobile Communications, and 4G long-term evolution. So this evolution of mobile network technologies, how 3GPP came up with the specification releases, what's the architecture involved in these generations, right? The protocols and the channels and all that related is what the focus of this particular module. Okay, so we will, as I told, we're going to focus on GSM. As such, the architecture is what is the current lecture focus on. So let's get started with GSM. So GSM is expanded as a global system for mobile communications, right? It is basically an European mobile telephone standard, right? And hence it's group special mobile, right? That's something called as global system for mobile communication. It became the global standard, right? It was initiated and by the ETSI, European Telecommunication Standardization Institute, right? And so if you look at here in GSM, right, GSM gave us all the flexibility, right, to support for scalable mobile digital subscribers, right. So that is the path that GSM has led us. Very successful generation of standard, right. And if you look at the case here, this is where from the bulkier phones we started to have low cost and low size handsets, and GSM, the 2G standard, is where the SIM card, right, the played a major role in terms of the subscribers identification and providing the service to the subscribers, right. So the introduction of SIM cards basically was coming up with the GSM standard. So it supported voice as well as data services. When it comes to digitized modulation here, it was a combination of the TDMA and the FDMA. So that is something that we will start looking at. So before getting on to that, the cellular band, if you start to look at, it goes on to use the 900 megahertz cellular band. Okay, so as well as the 1800 megahertz band, the PCS band, which is the personal communication system band, that's in Europe, right. And so depending upon the area, the country, you have the frequency regulations, the licensing and all that, right. So whereas in North America it was the 1900 megahertz band. Okay, so that is on the case, but going on to the so this is basically called as GSM 900, GSM 1800, GSM 1900, depending upon the country, the frequency of operation that's being used, right. So that's the 2G cellular communication system. It's a fully digitized technology which was offering much better speech quality, right. You go on to sample your speech signal, digitize it, quantize it, right, and then transmit this voice data, voice, right, and it was able to provide greater capacity and more users. It used frequency division duplexing. As you're aware of, there is the uplink and the downlink between the mobile subscriber and the base transceiver station, and the reverse link between the BTS and the mobile station. So there was a frequency division duplexing happening, but you have to accommodate multiple mobile subscriber units to increase the capacity simultaneously. So there was a combination of the TDMA and the FDMA technique being used in order to provide enhanced capacity. There was a very good ciphering encryption of your digitally encoded speech, right? And so all your calls were basically encrypted, right? So that was the case, and it was very well coexisting with the existing fixed line networks, which we call as the public switch telephone networks, right? And it also allowed worldwide roaming with a single number that was there. So international roaming was supported in GSM, right? So that's the case. Now let's get on with okay, the fundamental questions, right? When we go on with any mobile standards, right? So GSM, if you go on, any telephone network, if you look at, there is a caller and a callee, right? And there should be a connection established, and that's a basic service that you need to provide. So you have to set up the call, you have to maintain the call during the duration of the call. So in order to provide that service, you need to identify who is calling, where is he, right? Where is the call person? You need to determine the location of that, route the call so that you can establish the connection, right? And then terminate the call. So depending upon how long the duration of the call, you have to charge for the service. So this is a typical service that you are expecting. But the point now is, from a fixed wired network, right? When you have to expand that to a mobile network, that becomes even more complex. So the establishment of a call becomes much more complex task when you have the last miles where the mobile subscribers comes in. So you have, it might be from a mobile user to a landline call, right? It might be from a mobile to a mobile, or from landline to mobile, in all these cases. So we need to have this coexistence with the public switch telephone networks, and these GSM become necessary, right? Where it was able to provide services to the mobile users. So we have to find out the solution, right? Where is the subscriber? Who's the subscriber? What does he want? What type of service he wants? All this information, you have to do that, and accordingly you should be able to provide service and charge for the service that he's basically using. Correct. So that being said, that's the necessity for the digital, cellular standard of GSM. Before getting on to the architecture, let's look at the frequency bands involved in GSM, right? So as I told you, GSM 900 band, right? One is used for the uplink and the downlink, that if you look at, so 25 megahertz frequency band is used in the 900 megahertz range. So if you look at here, 890 megahertz to 915 megahertz band, right? 25 megahertz, that is being used for the reverse link, that is for the mobile subscriber unit to the base station transmissions, right? So that's for the reverse link. The forward link is from the base station to the mobile, right? So that, if you look the forward link, that's from 935 to 960 megahertz, right? So your uplink and your downlink, right, that you look at, your reverse link is from your mobile to the base station, right? So uplink and the base station to the mobile, the forward link, right, is the band from 935 to 960 megahertz. So 225 megahertz frequency band is being used, and totally, so you have an allocation of 50 megahertz in the 900 megahertz frequency band, right? So now you're going to use this spectrum very effectively. How is that being used? It's a combination of the FDMA and the TDMA, as I told you. So which means now, of the 25 megahertz that you have for the uplink and the downlink separately, right, you're going to now divide that into RF channels, right? So if you look at, every channel has a bandwidth of 200 kilohertz, right? And so how many such RF channels that you have? Each channel, the carrier channel, has a bandwidth of 200 kilohertz, and we're going to have 124 RF channels, right? And that's where the frequency division multiplexing comes in. So you've divided that into multiple channels, and these are 124 RF channels. Each channel is of bandwidth 200 kilohertz, and for every channel now, with which has 200 kilohertz, we are going to bring in TDMA here. On a time division multiple basis, we are going to divide every channel into further 8 time slots. Right, so when you have 124 RF channels operating on a frequency division multiple access basis, right, and in every channel you're going to operate on a TDMA basis where it's 8 time slots. So if you go on to multiply 124 into 8, you totally have 992 channels that can be realized for simultaneous transmission and reception of these two bands of 25 megahertz that you have. So that is how the frequency multiple access mechanisms comes into place to increase the capacity of the users by simultaneous transmission and the reception that happens in the downlink and the uplink via the FDD, right? So that is the case here. So that's what is summarized. So you have your 900 band, 1800 band, 1900 band. So we are focusing on the 900 band here, right? So that's the specification for the uplink, 890 to 915, 25 megahertz, 935 to 960, 25 megahertz for the downlink, right? So if you look at the separation between the uplink and the downlink frequency, there is basically 45 megahertz separation, right? And as it takes the advantage of FDMA and TDMA, in 25 megahertz bandwidth, 124 channels, 124 carriers are generated with the channel spacing. Each carrier has a bandwidth of 200 kilohertz, right? And so you're operating on FDMA, and every carrier you're dividing into 8 time slots. So at any specific time, 992 speech channels are made available in GSM 900, right? So that is on the 900. Typically, you have the specifications for 1800, you have the specifications for 1900, and so forth, right? So that's the idea behind the frequency, the license spectrum that you have, that we are typically using to enhance the capacity. Okay. Okay, so let us now get on to the network architecture of GSM. We will try to understand the components that are there, or the subsystems that are there in the GSM network architecture. So primarily, if you look at GSM network architecture, there are three major subsystems. One is your mobile station, right? We will use in short as EMS, right? That's your first subsystem. The second subsystem is your base station subsystem, which is called BSS, right? And the third subsystem is called as a network and switching subsystem, NSS, right? So these are the three major subsystems that we're going to have. So we will now try to understand each and every subsystem, right, from the architectural point of view. And so, right, now there's going to be a wireless part, and there's going to be a wired part coming in, infrastructure service and the infrastructure, wireless service that is there. So the wireless link interface, right, or you can call this as an air interface. So the air interface is between the mobile station and the base station subsystem, right? In the base station subsystem, if you look at, there is basically your base transceiver station, your base towers, right? And the towers that you have, the base transceiver station, BTS, which is going to be a part of that. So the air interface is between the mobile station and the BTS, which is part of the BSS. It's called as a wireless link interface. So the transmission over the air, the protocols involved, again the GSM gives you the specs for that, right? So the protocols involved in the transmission over the air interface, we'll have to understand. Secondly, now many BTS, right, are going to be there. Every cell there is going to be a BTS, right, and there's going to be multiple BTS for multiple cells, and many BTS are going to be controlled by a base station controller, right? So that is something as part of your base station subsystem. You're going to have your BTS and you're going to have your BSC, base station controllers, right? Now the BSCs, right, the base station controller is going to be connected to the mobile switching center, right? The mobile switching center goes on to become the core part of your network and switching subsystem, right? So these are going to be some of the key elements or the key subsystems that are going to be there as part of your GSM network architecture. Okay, so let me now put in a colorful picture and tell you. So when you look at the mobile station, right, you have your mobile equipment, which is your phone, smartphone that you have these days, right, the typical hardware, and it has a slot for you to put the SIM. So SIM is very important for you to provide for that subscriber to register onto the service provider and get hold of the service, right? So this forms a mobile station. The base station subsystem is going to contain several BTS, right, base transceiver stations, which ideally are going to be in every cell. There's going to be towers, right, which BTS, and these BTS are going to be controlled by the base station controllers, right? And so that's going to be the base station controllers are going to be connected to the mobile switching center, which is part of your network and switching subsystem, right? And the networks and switching subsystem, the BSS, is actually going to be maintained and going to be controlled by the operation and the support subsystem. That's called OSS. This is also another subsystem that comes in the operation and the maintenance center for the BSS and the NSS together, right? But the case is this: you have your base station subsystem, you have your network switching subsystem, you have your mobile station, right, and you have your operation and support subsystem. These are all the different subsystems that are going to be there as part of a mobile subscriber coming on to use a fixed infrastructure, right? That's what is the typical idea here. So when you have a mobile station, a mobile subscriber which is moving across different cells, these cells are, there's a proper planning that you do. We have looked at in the module 1, where the BTS is going to provide you service there, and the BTS in turn connects to the BSCs, and in turn connected to the MSCs. And the MSC, if you look at, there is a lot of database elements, software database elements that are there. We will look at each of these also, right, that are involved in terms of tracking your subscriber, tracking, registering, maintaining the calls, right, setting the call, routing the calls, right, and then charging them, right, registering them. So things like that comes on. You need database to store all that, right? So we will look at all those details. So so this is another better picture. This is taken from TL single book, right, where if you look at the mobile station, yes, you have your mobile equipment and the sim. If you go on to expand, it's a subscriber identity module. Okay, so that is the expansion that first you need to know. And then getting on to the base station subsystem, you have your BTS, which expands to base transceiver station, right? And several BTS, it's been connected to the base station controller, and it's controlled by the base station controller, BSCs, right? The BSCs are in turn connected to the mobile switching center, MSC, right? And the operation and the maintenance center, right? The operation support subsystem is basically going to maintain all these database and the call detail records and all that. So if you look at the several database elements that are there, there is something called as a home location register, HLR, something called as a visitor location register, VLR, something called as authentication center, AUC, something called as equipment identity register, EIR. So let us look at all these software database elements that are there, right, in detail when you look at each and every subsystems. Okay. So this again shows you another representation of the GSM architecture, the subsystems that are involved, right? So you have your mobile station, you have your BTS, the air interface, that is being used between the mobile station and the BTS for the protocols involved in the transmission over the air interface is specified by the GSM standard. It's called the UM in air interface, right? And the interface between the BTS and the BSCs, right? That's standardized, and it's called as a ABUS interface. Specifications and the transmission, the signaling protocol involved is being standardized. The interface between the BSCs and the MSCs is called the A interface. Here it goes on to use signaling protocol, which is called as SS7, signaling system 7 protocol, right? So all these are standardized interfaces, well-defined interface between the mobile station to the BTS, between the BTS and the BSCs, between the BSCs and the MSCs. right, and all other software database elements that is there. And these mobile switching center, the part of the networks and switching subsystem is connected to your public switch telephone network, right? And you have the operations and the maintenance center controlling and maintaining these subsystems, right? So that's something on the three major subsystems that you have. There is some interface standard specs that are followed, right? In order for the transmission and the reception to happen, there are protocols, followed, as per the GSM specifications. Okay. So let's get on one by one on the subsystem. So as you're aware of the mobile station, right? The mobile station communicates over the air with the base station transceiver, the BTS, right? And you have in the cell, you have the mobile station getting the service via the BTS, correct? And so it communicates over the air interface. Okay, so that's the first thing. So the kind of the user information, right? The speech has to be transmitted, and the protocols has to be modified with the air interface standards, right? So that is the case here. So the user voice information is interfaced with the mobile station through the microphone and the speaker for the speech, the keypad and the display for the short messaging, and the cable connection for the other data terminals, right? So the mobile station is something which you see is going to consist of your mobile handset with the battery and the SIM card, the module to insert your SIM card. The SIM card stands for your subscriber identity module, right? So if you look at this handset, I hope you all know, if you look at your handset, just like how every device has a MAC address, a physical address, right? Your mobile equipment, your handset has a unique identity number. That's like your hardware address, right? So that is called as a IMEI. It stands for International Mobile Equipment Identity. IMEI number is like your hardware address. It's for your equipment. Your mobile equipment has a unique identity number, right? This is installed in the phone at the time of manufacturing and cannot be changed, just like your hardware address, your MAC address that you have for that, right? Now this IMEI is actually being accessed by the network during the registration to check whether so there are cases here to find out whether it is a stolen phone, or and all that. You use to use your IMEI, and also for registering, you need to have your IMEI, right? So mobile equipment unique identity number is a very important entity. In even all these counterfeit issues, the IMEI could be used, for tracking and all that, right? So that's one of the thing. Then the SIM, right? SIM, basically the subscriber identity module, is going to contain the information that provides the identity of the user to the network.